catch up and delay the megawatts coming on board, but there's no doubt that we are going to get tens of thousands of megawatts of new wind capacity brought online in the next decade. Again, for shutting down coal plants, you run into a capacity factor issue and the characteristics, certainly in some parts of the country. Natural gas is going to be a very competitive fuel with the new shale discoveries coming online. I don't think natural gas or wind is going to get a free ride over the next decade. Both have problems they're going to deal with. Natural gas has environmental issues from the hydrofracking that is producing all the new natural gas supplies that are being touted. You're already seeing in various parts of the country shale fields being taken off the exploration market because of environmental issues. And I think the jury is still out on how sustainable the flows are from these new natural gas shale fields. I think you'll find out from the Barnett Shale before long if they're going to keep flowing at the rate they initially start at, and what the economic recovery period is for some of these fields. Wind will continue to face transmission issues, and frankly, we're doing better here in Texas under the PUC than the rest of the country is so far, and addressing that for various reasons. I don't envy John's position dealing with transmission around the country. I know some of those CEOs in Georgia and other places that are not happy about the prospect of paying for wind transmission in Oregon and Maine and other parts of the country. It's a difficult problem to solve. And I think wind also will continue to have some siting problems that will come up on a regional basis. So those are the two main industries, I think, that will be taking the lion's share of the growth over the next decade. But I also think that we're starting to approach a tipping point for solar photovoltaics. And solar photovoltaics are experiencing very high growth right now in terms of percentage growth, but it's still a small piece of the overall energy market. And you hear people talk about, rightly so, that there's a difference between new products taking off in consumer electronics like iPhones and such, and then in the power generation field, it takes decades to transition and bring on new technologies and so forth. I'm not sure that's going to be the case for distributed PV. Distributed PV is much closer to characteristics of the consumer electronics market. And particularly when we have a couple of breakthroughs that are coming. There's the conventional PV installations, which are taking off at very high rates now, and the costs are getting down in manufacturing, approaching that $1 a watt manufacturing cost. There is also the idea that is finally taking hold in mass production of the built-in photovoltaics on roofing materials. And some big players like Dow are starting to enter that game. And when the roofing material starts to get very close to conventional roofing materials, and it doesn't make a lot of difference whether it generates energy or not in the cost, there is an explosive market there when you think about the roofing turnover in this nation on an annual basis. That, and because of nanotechnology advances, we're approaching a breakthrough, I think, in the mass area application of solar, reaching the point that an ink-like substance can be sprayed onto mass area surfaces and generate electricity. The combination of those things could lead to a really explosive growth in the use of PV on a distributed basis. And it will also be the leader in what's starting to be called micro-harvesting of energy, which I'll mention again in a moment. So I have very high hopes for not so much in the next few years, more toward the end of this decade and the beginning of the next decade. I think solar PV will take off, and at some point, and as an old anti-nuclear activist, I love saying this, at some point solar power will be too cheap to meter. But you know, I think the biggest change we're going to see, and it will just start to emerge this decade, but into the future decades, it's going to be on the building side. The current trends that you hear most talk about are zero energy buildings and the smart grid. And zero energy buildings are a great concept. Here in Austin, we're changing our building code so that all new single-family homes built in Austin starting in 2015 will be required by code to be net zero energy capable buildings. And we're well on our way to meeting that target. I don't think you can do that with commercial buildings, and I have friends in California that's promoting zero energy commercial buildings. I think the loads there are not going to be met by on-site generation. And frankly, I think the residential zero energy buildings are not going to stay zero energy very long when we start plugging in plug-in hybrids and electric vehicles. And I think there are other loads that are coming on the residential side that we're not thinking about yet. And if you look at the history of building, you'll see that we actually have been more efficient in our building over time. Today's modern home would be a zero energy building if we hadn't increased the plug load from electronics and computers and all the other stuff that's come online. And I think there's some major new loads pending out there. I think domestic robotics will come online as a major new load, and eventually you'll see even more in on-site manufacturing. And if that sounds far out, you need to Google 3D printers and think about the consequences of that technology expanding in scope. The smart grid will have an impact on reduction of loads. I think it's perhaps being a little overhyped in terms of the lasting consequence of smart grid, but it certainly is a game changer in terms of energy consumption on the site and giving residents control of their technology. But micro-harvesting is a term that you'll start hearing more of. I don't know if that's the term that'll catch on, but more and more we're developing the technologies where the actual materials, where it's in a house or a car or the paints or the coverings for appliances, the materials are going to start to capture the ambient light and radiant energy and thermal shifts and mechanical movements and convert those to useful energy. It essentially can handle all of what we're calling the vampire loads in the house this time, and the coverings on the cars and the materials will become both energy generators and energy storage on site. You'll also combine that with ubiquitous sensing, and in the past few weeks have been major announcements in the scientific community about batteryless radio devices and others where the sensing can operate without the need for storage of energy just from the ambient energy use around it. Fuel cells will come back, low power wind, and so forth. And so let me end this with a thought that I've been pondering for the last few months at least. I am wondering if we are starting to see the initial emergence of energy sentient buildings. And energy sentient buildings are buildings that start to not only generate but store and dispatch all the on-site energy potential of that building and communicate with the electric grid and communicate with the transportation sector and the internet and so forth. Now, energy sentient buildings are a very disturbing thought to many people, and some people squirm in their seat and said, my gosh, he isn't saying that buildings are going to become conscious, is he? Well, that's an interesting thought. And as a matter of fact, one of the philosophers of consciousness theory, leading philosophers, David Chalmers, has written an article asking, is a thermostat conscious? And it gets into very interesting philosophical debate on the origins of consciousness and the role of thermostats and so forth. And one of the issues in the smart grid is that consumers are initially going to play with all their devices and cut their load and so forth, and they're going to stop doing that after a couple of months. They're going to need an artificial intelligence type device to interface between the electric grid and their building to control